Part C, suggest why the use of GM chymosin is more ethically sound than using chymosin from animal rennet. Well, you do need to kill the animal to get the rennet, which vegetarians who don't eat meat wouldn't want that to happen if they wanted some cheese, for example. And generally, it's probably better. So, ethical reasons would not have to kill the animal. Then we've got an experiment. We've got genetically engineered E. coli, so it's had its DNA changed, and it can now make chymosin, whereas normal E. coli wouldn't be able to. And they grow it on milk agar, so agar that's got milk in it. It's left for a day, 24 hours at 37 degrees. And what we've got going on here is where the milk is broken down by the enzymes, then that is a clear circle there. This should remind you, if you've done another experiment with starch agar, it's the same sort of thing that you might have come across in nutrition. So suggest why the bacteria are cultured at 37 degrees and why an unmodified strain, this strain here, is included. So 37 degrees, that's body temperature for mammals more or less. So that's where the enzymes will have their optimum. So body temperature of mammals, and it's not in this mark scheme, but I would always talked about optimum temperature for enzymes in mammals. And this unmodified E. coli, you see nothing's happened, but that's exactly what they want. The control is to show that it's the effect of whatever they're testing, this GM E. coli. So in a control or a control experiment, we expect nothing to happen. If something does happen, then we know there's a problem with the experiment. So unmodified E. coli acting as a control experiment, and it won't produce protease, and so it's just really testing that the experiment is running correctly. Then we've got a calculation. So we've got how much milk is in the agar, that is that there, and this is the clear zones where the milk has been digested. Strain 3, that one, and that is 13 millimeters in diameter. So we've got 13 millimeters in diameter, and it's 3 millimeter depth. This agar's got a depth to it. If I draw it on like that, I might kind of show you. This is deep, so 3 millimeters deep. And the first calculation is to find out the volume of that using this equation, pi r squared h. So volume equals pi, which they give you 3.142, r squared h. R is the radius, that's the diameter, so half of the diameter, so the radius is half of 13. So 13 divided by 2 is 6.5, as that's the diameter, and the height is the height of the cylinder there. The units that they want this in eventually is cm cubed, and we're currently working in millimeters. So we need to convert these into centimeters to start with. So the radius, 6.5 millimeters, is 0.65 centimeters. The height instead of 3 millimeters is 0.3 centimeters. If you're unsure between the connection between, or the relationship between millimeters and centimeters, this is millimeters, so 10 millimeters there is 1 centimeter. So that's 1 centimeter is 10 millimeters. I'll look at it this way around. 1 centimeter is 10 of these little millimeters. So we just need to pop those in to this equation. So pi 3.142 times by r, 0.65 times by r again, 0.65 times by h, which is 0.3. When we do that, 3.142 times by 0.65 times by 0.65 times by 0.3 is 0.3982485. And express your answer to 1 decimal place. So 1 decimal place is this one here. So we can have 0.3, or we're going to have to round it up to 0.4 because it's 0.39. So 0.4 cm cubed. And the next little bit of the problem is the mass of milk. Well, we know that the information it's given us is that a 1 cm cubed, so 1 centimeter, no, 1 contains 0.02 grams. So 0.02 grams in 1 centimeter cubed. But we haven't got 1 centimeter cubed, we've got 0.4. So you can almost guess what the answer's going to be. It's going to be less than this number here. So if you get an answer that's bigger than that, then you know you're doing it wrong. And also it wants per hour, and we're currently in per day. So the first part is taking our 0.4, and we haven't got 1, we've only got 0.04 of these, so of 0.02. We take that times by our 0.02 is 0.0079649. So that is actually in grams now, so that's how many grams we've got. But that's per day, because it told us it was in 24 hours. So to get that per hour, we need to divide that by 12. So we need to divide by 24, sorry, 24. So divide that by 24 is this number here, 0.00033318. And express your answer in standard form. So standard form is a number between 1 and 10. So on this it'll be 3 point whatever, it depends how many decimal places. I'll just use 1 decimal place. So 3.3, we don't need to round that up. And then we go, how many? 1, 2, 3, 4. I've moved the decimal place 4. So times by 10 to the minus 4. And that's your answer there.